Hi students, welcome to ACE online platform. Here we are going to talk about ISRO exam, and this is a session which is targeted for the electrical engineering students who are preparing for the ISRO 2025. Fine. So, what we are going to do in this session, we are going to take up some previous questions, and along with the previous questions we are going to revise some concepts, so that you will understand what is the level of questions asked, what is the type of questions asked. Fine. So, here we will be targeting, we will be dealing with electromagnetic fields. Fine. So, when it comes to the electromagnetic fields, as far as syllabus is concerned, somehow it is same as a GATE syllabus. Fine. So, and one more thing here, you will find there is no much question, actually frankly speaking, there is no much questions from this subject. So, you will find the questions here and there, 2 to 3 questions from this subject. Fine. So, which among the following statements is true? As you all know, this is related to the stationary charge and charge which is at the rest, stationary charge and moving charge. Fine. So, as you all know, what is the origin for the entire electromagnetic theory? The origin for the entire electromagnetic theory is a basic charge. If you have a charge, there is an electric field around it. If I keep this charge under the motion, charge under the motion constitutes current or gives current, and the current carrying conductor will have a magnetic field around it. Fine. So, there is a magnetic field and electric field. Suppose on the other hand, in the third case, I will going to accelerate or deaccelerate the charges. So, when you have accelerated and deaccelerated charges, there will be a both electric and magnetic field. Not only that, there is a coexistence of both electric and magnetic fields, which is called EM phenomena. Fine. So, this is a gist of the entire electromagnetic theory. It is a summary of the entire electromagnetic phenomena, which is explained with the 4 Maxwell's equations. Fine. So, come back to these statements here. What are the statements he is asking for? The electric charge can produce the electric field and magnetic field when it is stationary. No. When the charge is at rest, it can generate only the electric field, but not a magnetic field. Wrong statement. Electric charge can produce the electric field when stationary and both electric and magnetic fields when moving. Yes, it is correct. So, when the charge is moving, when the charge is at rest, when the charge is stationary, it can generate the electric field. When the charge is moving, it can generate the both electric and magnetic fields. This is a correct statement. Observe the third statement. The electric charge can produce the electric field when moving and magnetic field when stationary. It is completely quite reverse, isn't it? So, it is a wrong statement. Last one, electric charge can produce the electric field and magnetic field while stationary and while moving. Wrong. Yes. So, when it is at stationary, it can generate only the electric field. Wrong statement. Obviously, for a given question, option B is answer. See, what is the level of questions asked? What is the type of a questions asked? That is our intention. Fine. Anyhow, let us have next question. Which of the following statement is true for the divergence of electric and magnetic field densities? What you know from the Maxwell's equations? Let me write down the Maxwell's equations. So, we are going to follow this order. So, curl of H is equal to J plus dou D by dou T. Second one, curl of E is equal to minus dou B by dou T. Third one, divergence of D is equal to rho V. Fourth one, divergence of B is equal to 0. These are the Maxwell's equations in the differential form, and there is one more form which is called integral form. Let me write down those things also for your reference. What is the integral form of Maxwell's equations? Closed line integral of HDL is equal to surface integral of J plus dou D by dou T. This is the integral form. Very important Maxwell's equations. You will directly get the questions. You can see in the previous papers, here and there you will find the questions on identification of Maxwell's equations. Fine. So, if there are some, there is a more chance, if there are some 4 questions from this subject, 1 question will be from the Maxwell's equations. Fine. So, not on numericals, just based on the identification of Maxwell's equations. Fine. So, here it is, next one is closed line integral of EDL, which is equal to minus surface integral of dou V by dou T dot dA. Next one is closed surface integral of D dot dA is equal to volume integral of rho V into dV. Next one is closed surface integral of B dot dA is equal to 0. Here there is one more equation which is not a Maxwell equation, which is called continuity equation. Divergence of J is equal to minus dou rho V by dou T. Here closed surface integral of J is equal to minus volume integral of dou rho V by dou T into dV. Suppose if it is a static case, what happens? This will be 0, this will be 0, this will be not that one, this will be 0, this will be 0 for the static case. So, this will be 0, this will be 0. So, you should know the Maxwell's equations in the static case also. Better you remember these things. These are in the time varying case. For the static case, you can just modify them. Okay. So, there are more chances of getting the questions on this one. So, the questions will be based on identification of equations. He will give that set of equations. From there, he will ask you to identify the appropriate Maxwell equation. Fine. You should know the physical meaning of all these things also. Fine. So, come back to the question here. So, we have revised something and come back to the question here. Let us try to answer this one. So, what is the question here is, which of the following statement is true for the divergence of electric and magnetic flux densities? Both are 0. No, wrong. Both are not 0. Divergence of D, that means divergence of electric flux density is volume charge. Divergence of magnetic flux density is 0. Go back here. Both are 0 is wrong statement. Both are 0 for the static field densities and non-zero for the time varying fields. It is a wrong statement. Whether it is a static or time varying does not matter, because there is no time dependence term here. It is always true for the static case and as well as for the time varying case. Okay. So, it is 0 for the electric flux density rho. No, wrong statement. Electric flux density, it is non-zero. Divergence of D is equal to rho V. It is 0 for magnetic flux density. Yes, this is correct. Option D is the correct one. So, like this, my intention is to show you, and like this theory questions can be formed on these Maxwell's equations. The question can be like, what is the conservative property of electrostatic field? Conservative means curl of E is 0. Which equation represents the non-existence of magnetic monopole, that is divergence of B is equal to 0. What was the correction made by the Maxwell, which is displacement current? What are the coupled equations? These two are coupled equations. What is the necessary condition for the EM phenomena to exist? This one. Like this, theory based questions, theoretical questions are framed on these Maxwell's equations. So, go through them, important. Fine. Here is a sample question for you. Okay. Anyhow, let us proceed further. See one more question. Yes. Which among the following Maxwell's equations represents the conservative property of electric field? What is the conservative property? Suppose if we consider the static case. For the static case, dou by dou T is 0. We have del cross E is equal to minus dou B by dou T. So, if it is a static case, dou by dou T is 0. It is a conservative property. If you want to write this one in the integral form, what happens? This will simply become closed line integral of EDL. If a curl of any vector goes 0, then it is called conservative field. That means line integral is only function of location of initial and location of final points, but not of the shape of the contour chosen. Fine. So, what is the answer from here? Curl of E is equal to 0. Option A is the answer. Fine. Let us proceed further. Yes, here is a question which is based on the formula. So, here a solid non-magnetic conductor of a circular cross section has its radius on z axis and carries a uniformly distributed total current of 60 amperes in the z direction. If the radius of the conductor is 4 mm, find the magnitude of the flux density at rho is equal to 5 mm. Okay. So, see here, actually you need to deal with Ampere's law here. Let me draw some diagram here so that you will understand. So, here is a cylinder. $60 amperes. This is having a radius of 4 mm. He is not asking what is the magnetic field inside, he is asking what is the magnetic field outside. When you are, if you want to find out what is the magnetic field inside, you can make use of Ampere's law. Once you come out from the current carrying conductor, once if you come out from the cylinder, it is a simple 60 amperes current carrying conductor. You can make use of the formula. What is the formula? A magnetic field due to infinite uniform line current. Okay. So, he is asking outside. So, the radius is only up to 4 mm. He is asking outside, it is a 5 mm. So, what is the formula? What is the formula? Let me turn the page here. The formula is asking for the flux density B. Flux density, what is the B? I will going to take only the magnitude. B is equal to, did he mention any medium? In the free space, obviously. So, here mu naught into I divided by 2 pi rho. So, which is 4 pi into 10 to the power of minus 7 into 60 divided by 2 pi into 5 mm, 5 into 10 to the power of minus 3. So, it is 2 into 60 into 10 to the power of minus 7 into 10 to the power of 3 divided by 5. So, it is 12, 24 into 10 to the power of minus 4. It is 2.4 milli. 2.4 into 10 to the power of minus 3 Tesla, or B is equal to 2.4 milli Tesla or milli Weber per meter square, 2.4. Let me go back here. So, option C is the answer. So, this question is formula based. Fine. So, what are the formulas you must remember from the electrostatics and magnetostatics? Electric field due to, let me write down, otherwise let me turn the page here. So, what are the formulas which need to be remembered? So, it is a, there are four formulas you must remember for your exam. Electric field due to infinite uniform line charge, E is equal to rho L divided by 2 pi epsilon rho cap. This is electric field due to infinite uniform line charge. The other one is electric field due to infinite uniform sheet charge. It is rho s 2 epsilon plus or minus n cap. This is other formula from the electrostatics. From the magnetostatics, you have to remember magnetic field due to finite length current carrying conductor mu I by 4 pi rho into sin alpha 1 plus sin alpha 2 into phi cap. The other one is magnetic field due to the finite length current carrying conductor, infinite length current carrying conductor mu I by 2 pi rho into phi cap. The other one is magnetic field due to circular loop, B is equal to mu I a square divided by 2 into a square plus b square to the power of 3 by 2. This is a magnetic field due to circular loop which is having a radius a and away from the center at a distance of b. Suppose if you want to find out what is the magnetic field at the center, B is equal to mu I by 2a. Okay. So, these are the important formulas which you must remember for your exam. So, these are from the electrostatics, these are from the magnetostatics. Okay, fine. Let us proceed further. Here is a one more question. Yes. The magnetic flux density in the magnetic material with susceptibility, it is chi m is equal to 6 in a given region as B is equal to 0.005 y square x cap Tesla. Find the magnitude of the current density J at y is equal to 0.4 meters. So, again this is based on the Maxwell's equation. So, here magnetic field is not dependent on the time, it is only dependent on the space. So, how do you find out its corresponding current density? You have to make use of this one. See how questions are directly formula based. Okay. So, what we know is del cross H is equal to J plus dou d by dou t. So, it is not dependent on the time. So, this is 0. So, J is equal to del cross H, but what is given is a B. So, you can multiply and divide by mu by mu into H. Mu into H is nothing but a B. So, it is 1 by mu, you can take it out. So, del cross B. What is this mu? Mu is equal to mu naught mu r, where mu r is equal to 1 plus, actually standard representation is chi m. So, it is Zm, but he said susceptibility. So, it is 1 plus 6. So, mu r is equal to 7. Okay. So, mu is equal to 7 into mu naught. You need to find out the curl of B. I am going to turn the page here. So, what is the curl of B? A determinant of x cap dou by dou x, it is the x component 0.05 y square y cap dou by dou y 0 z cap dou by dou z 0. So, it is x cap into this minus this into 0 minus 0 minus y cap into this minus this into 0 minus 0 z cap into this minus 0.2 into 0.005 y. So, curl of B is equal to minus 2 into 5 divided by 1000 y z cap. So, it is minus 1 by 100 y cap. So, it is the curl of B. Okay. So, once you got a curl of B, you can find out this J. J is equal to 1 by mu into J is equal to 1 by mu into curl of B. 1 divided by mu naught into 7 into mu naught into minus 1 by 100 into y cap. Okay. So, it is minus 1 by 7 into 4 pi into 10 to the power of minus 7 into so yes, you can make here, there is a 7 here, none is also there in the option. Okay, you must be careful. So, here it is, what happens? So, take this one into the numerator, it is minus 10 to the power of minus 7. So, this will become 10 to the power of minus 4, 7 into 4 pi into y cap, it is J. He is asking what is the magnitude of the J, it is 10 to the power of minus 4 divided by 7 into 4 pi into y cap. It is a plus here, okay, plus. It is a plus, fine. But there is a 4 pi here. How can you miss that 4 pi? Here 10 to the power of 4 divided by 7 pi ampere per meter square. Yes, but none of the above is answer. 4 pi is missing here. Fine. There is a 7 pi, but 4 is also there. So what is the answer here? Option D is the answer. Okay. Let us have one more question. Yes, these are directly formula based. He is asking us to find out the formula. What is the formula? The internal inductance of the straight wire of a circular cross section with a radius r and length L and permeability mu is. See here guys, there is a internal inductance of the straight wire is given by, this is a formula you have to remember, some standard formulas you have to remember. Inductance and capacitance of the coaxial cable, spherical capacitor, okay, these are the some of the standard things. So it is mu L by, formula is mu L by 8 pi. But if you observe here, in the question he said internal inductance. If you observe here, there is no such thing. Fine. So it is mu L by 8 pi, but Henry per meter, it is not a Henry. So this is also correct. Suppose if you bring this one other side, so you must be little bit cautious here. If you know the concept and everything, but if you do not choose the options properly, you will go wrong. It is Henry here. It is a Henry per meter. Okay. So what is the answer here? Option C is the answer. Clear? Fine. Next, determine the energy density in the free space created by the magnetic field intensity H. Energy density is asking. What is the energy density? See, all these questions are directly formula based questions. That is how the questions are asked. What is the energy density in the magnetic field? Is equal to half mu H magnitude square. Fine. So it is 1 by 2 into 4 pi into 10 to the power of minus 7 into mu r. What is the mu r? He said free space. So it is the 1 into H magnitude. What is the H magnitude? It is 3 whole square. So this is 2 pi into 10 to the power of minus 7 into 10 to the power of 6. It is 0.2 pi. It is, so this is, yes. So this one is so adjust this answer according to the options. So it is 6.28 into 10 to the power of minus 1. So convert into millis here. Fine. So this can be written as 628 into 10 to the power of minus 3. So what is this energy stored? 628 millijoule per meter cube. So what is the answer guys? Option C is the answer. Fine. So this is the energy density for the magnetic field. What is the energy density in the electric field? Let me discuss that one also. So energy density in the magnetic field is actually 1 by 2 into B dot product with H. This is also equal to 1 by 2 into mu H magnitude square. Units are joule per meter cube. What is the energy density in the electric field guys? Something similar. Of D dot E. Okay. This is also equal to 1 by 2 into epsilon into E magnitude square. Units are joule per meter cube. Okay. So it is something similar to what you would have learnt in your circuit theory of L I square of CV square. Okay. Fine. So there is a one more question here. Yes, this is also based on purely on the formula. So for this kind of, see, in when you compare this electromagnetic theory with other subjects, in the electromagnetic theory obviously you need little bit of visualization. Visualization is required, fine. So, for that I will strongly recommend you to go through some 3D images. You can take any textbook or any Google images. So, observe the images, so that will improve your visualization capacity, fine. So, why? Because knowing the formula, knowing the concept is not enough in our subject. You should have some little bit visualization, fine. Anyhow, we will going to draw a diagram here so that you will understand it, fine. So, it is also purely based on the formula, options are missing, does not matter. For infinite sheets of charge with the following uniform charge densities are placed at different points in the space as following. So, the sheet 20 picocoulomb per meter square at y is equal to 7, minus 8 picocoulomb per meter square at y is equal to 3, 6 picocoulomb per meter square at y is equal to minus 1, minus 18 picocoulombs at y is equal to minus 4, and so on, not so on, only 4 sheets. Find the magnitude of the electric field E at a point 2, 6, minus 4. Consider the relative permittivity of the medium as a 1. Fine. Let me turn the page here. Let me draw some rough diagram here. This is x axis, this is y axis, this is z axis. So, where these sheets are located, y is equal to minus 4. Y is equal to minus 4, y is equal to minus 1, this is y is equal to minus 4, y is equal to minus 1, y is equal to 3. Y is equal to 7. What is the charge on these things? So, we will minus 18 picocoulomb, everything is pico. So, it is minus 18, better you put this one in the bracket and treat this as a positive charge. And then 6, and then this is minus 8, put this one inside the bracket. Next 20. Okay. So, where is asking us to find out the electric field 2, 6, minus 4, 2, 6, minus 4. So, you can notice here the y value is 6. That means, where is that point? That point is somewhere here. Why? Because y value is 6. So, what is the electric field due to all these things? Due to this one, the electric field is downwards. Due to this one, the electric field is upwards. Here upwards, here upwards. So, due to this one, the electric field is positive y. This is negative y. Fine. So, let us use the formula here. What is the formula? E is equal to rho s by 2 epsilon naught plus or minus n cap. N is a normal here. So, what is the overall electric field there at a point P? Minus 8 pico 10 to the power of minus 12 divided by 2 epsilon naught, it is in the y direction, because I have taken the charge along with the negative sign. So, it is 6 into 10 to the power of minus 12 divided by 2 epsilon naught into y cap plus minus 18 into 10 to the power of minus 12 divided by 2 epsilon naught y cap. And what about due to this one, the electric field is pointing downwards, that is in the negative y direction. So, it is minus of 20 into 10 to the power of minus 12 divided by 2 epsilon naught y cap. So, EP is equal to minus 8 plus 6 minus 18 minus 20. Okay. It is asking anyhow magnitude. So, 10 to the power of minus 12 divided by 2 epsilon naught into y cap. So, this is 20, it is minus 40. So, it is minus 40 into 10 to the power of minus 12 divided by 2 into 1 by 36 pi into 10 to the power of 9 into y cap. So, it is minus 20 into 9 pi into 10 to the power of 9 into 10 to the power of minus 12 into y cap. Okay. So, finish the calculation. He is asking only for the magnitude. So, the magnitude of EP is 20 into 9 pi into 10 to the power of minus 3, 18 pi into 10 to the power of minus 2. So, EP is 0.18 pi volt per meter. This is answer. Clear guys? Let us have one more question. It is purely formula based question. Okay. Yes, here is a question. So, here you need a coordinate system, along with that you need what is called a Gauss law. So, a 25 microcoulomb point charge is located at a origin. Calculate the electric flux passes through the portion of the sphere defined by r is equal to 20 centimeters and theta is 0 to pi and phi is from 0 to pi by 2. So, let me try to draw what kind of shape is this for the sphere. Suppose if you take the coordinate system, here is the coordinate system, this is x, this is y, this is z. Theta is ranging from 0 to phi, theta here is ranging from 0 to phi, okay, and phi is ranging from 0 to pi by 2. So, phi is 0 here, 90 here. So, what kind of shape is this? Okay. So, try to imagine this one. What kind of shape is this? Think about the apple. It is a 1/4 of the apple. Yes, if you think apple like this, if you cut it like this, cut it like this. So, this is one of the piece. So, it is a 1/4. And what it is said in the question? The charge is placed at the origin. So, the charge is placed here. How much charge? 25 microcoulombs. So, what is the flux coming out of any closed surface? Net electric flux is equal to charge enclosed, isn't it? Suppose if this would have a sphere, then what is the, hope you have understood this one, this portion, one more portion, that side, this side. So, the 4 portions leads to what is called a sphere. Fine. Suppose if this would have a sphere, so if the charge is placed inside, what is the total flux coming out? The total flux is 25 microcoulombs. Let me call this as a total 25 microcoulombs. But that is not the question. It is asking how much is the flux crossing through this portion. Because of the symmetry, what you can do? Exactly, you can make that one. So, what is the flux crossing through that section? Flux crossing through that given section is 25 microcoulombs divided by 4. Yes, so it is 6.25. So, little bit logical thinking, little bit visualization is required, concept is required, visualization is required. What is the concept? Gauss law. So, the net electric flux coming out of any closed surface is equal to charge enclosed by that. That is the concept. Along with that, you should have little bit of idea on the coordinate system. That is the reason why I am strongly recommending you people to go through some images, 3D images. So, take any standard textbook, refer, observe those figures, that will going to enhance, that will going to enable us in getting a proper visualization. Yes, let us have one more question here. A dielectric material is placed in the vacuum. The electric field E is equal to 4 volt per meter. What is the electric field inside the material if the relative permittivity of the dielectric material is 2? See, when the fields are interacting from one medium to the other medium, electric flux density remains same. Okay. So, electric flux density in the air and electric flux density in the dielectric are same. So, when it is in the air, epsilon naught into air, epsilon naught epsilon r into dielectric. So, here what is the electric, you can cancel out these two things. So, epsilon r into d. So, what is the electric field in the air? It is a 4. What is epsilon r? It is a 2. So, what is the electric field d? Electric field in the dielectric medium is 2 volt per meter. So, what is the answer here? Option C is the answer. Fine. Let us have one more question. Yes. Yes. See here, it is also directly purely based on formula. Find the relative permittivity of the dielectric material used in the parallel plate capacitor if the electric flux density D is equal to 15 microcoulomb per meter square and energy density 20 joule per meter cube is given. Fine. So, as I said earlier, what is the energy density formula? Energy density in the magnetic field is 1 by 2 into d E, 1 by 2 into epsilon into E magnitude square. But what is given in the question is a d. So, I will convert this one also into the d. How? I will make an adjustment according to the question. So, where I will going to turn the page here. So, it is the 20 we need here epsilon r, yes. So, make adjustment. So, in a single step we can substitute all the values. So, epsilon r is equal to d magnitude square divided by 2 into epsilon naught into energy density in the magnetic field. So, it is d, it is 15 into 10 to the power of minus 6 whole square divided by 2 into 1 divided by 36 pi into 10 to the power of 9 into what is the energy density here, it is a 20. So, what is this epsilon r? Check out this one, it is a 0.6, there is no units for this one, check out its value. So, option 6, option A is the answer. Fine, let us have one more question. Yes. See, you have by this time you would have understood what is the level of the questions here. Fine. For homogeneous medium with the volume charge density rho v and the permittivity epsilon, the voltage V and what is this del square V? This is a Poisson's equation directly. So, del square V. How do you obtain this Poisson's equation? By combining the divergence and gradient. So, the divergence of D is equal to rho V. But what is this D? D is equal to epsilon into E, which is equal to rho V. He said homogeneous medium. For the homogeneous medium, epsilon is constant. You can bring that one outside. Divergence of E is equal to rho V. So, divergence of E is equal to rho V by epsilon. So, where we are using this word homogeneous? Here you can bring this epsilon outside and you can substitute E is equal to minus gradient of V. So, this will become divergence of minus gradient of V, it is rho V by epsilon. So, this will become del square V is equal to minus rho V by epsilon. This is called Poisson's equation, isn't it? Directly it is minus rho V by epsilon. Option D is answer. Okay guys. Next, this is a directly formula based question. Which among the following equation is true for the steady magnetic field, where B is a magnetic flux density and J is a current density? So, divergence of no, see here, what do you know from the steady magnetic field? Go back to the Maxwell's equations. If it is a steady magnetic field, yes, if it is a steady magnetic field, curl of B is this differentiation is 0, divergence of B is 0. So, what happens if it is a steady magnetic field? Curl of E is equal to 0, divergence of B is equal to 0. Can you make any changes here? Divergence of B is equal to J is a wrong statement. Curl of B is 0, no, curl of E is 0. Curl of H, and there is one more thing you can do. What you can do? If it is a steady field, this will be 0, isn't it? Del cross H is equal to J. Del cross H is equal to J. See, he did not mention anything about the medium. So, you can make a modification here. If mu is constant, you can bring that one outside, you can bring that one other side, but nothing is mentioned. But what I also said is curl of B is equal to J, it is a wrong statement. If at all, if this mu is a constant, you can bring that one other side, curl of B will be equal to mu into J. So, this is a wrong statement. None of the above is the answer. Okay, fine. Let us have one more question. Which among the following statement is correct regarding an ideal conductor in the static electric field? So, if it is a static electric, see theory question again. If it is a static electric field, inside the perfect conductor electric field is 0, on the conductor electric field exists, but in the normal direction, fine. So, observe the statements here. Static electric field intensity inside the conductor is non-zero, wrong statement. Static electric field outside the conductor is 0, wrong statement. Static electric field intensity at the surface of the conductor is directly normal to the surface, correct statement. Static field intensity at the surface of the conductor is directly parallel to the surface, wrong statement. So, what is the answer? Option C is the answer. Fine, let us proceed further. What is the volume charge density at a point 1, 2, 1 associated with the electric flux density D? Okay guys. So, directly you can make use of Gauss law. What is this rho v here? The rho v is equal to divergence of D. Formula based, it is dou by dou x of x y square plus dou by dou y of y x square plus dou by dou z of z. Correct? So, rho v is equal to, so it is a y square plus it is x square plus 1. He is asking at a point, substitute that point, it is 2 square plus 1 square plus 1, 4 plus 2 which is 6. So, rho v is equal to 6 coulomb per meter cube. Option A is the answer. Fine, let us have one more question, directly formula based. Here is a question, yes, this is a Coulomb's law based. So, the electric field intensity at a point situated 4 meters from the point charge is 200 Newton per Coulomb. If the distance is reduced to 2 meters, the field intensity will be. So how the electric field, what is the electric field guys? Just I will take the magnitude. Electric field E is equal to Q divided by 4 pi epsilon r square. So, how it is dependent on the distance? It is 1 by r square. Suppose if the distance is halved, then what happens? If distance is halved, so it is 4 divided by r square, it is multiplied with the 4 times. So, this must be multiplied with the 4. So, 200 into 4, it is a 800 Newton Coulomb. Everything is same. Simple, see, such a simple questions are also asked. Fine, let us have one more question. Hollow metallic sphere of radius r is kept at a potential of 1 volt. The total electric flux coming out of the concentric spherical surface of radius r is. See, these are directly, this is a gate question, gate electrical question, 2 marks question. Fine, interesting. See here, there is a sphere, hollow metallic sphere of radius small r is kept. It is a sphere. There is a sphere here. It is having a radius of r and connected to the potential of 1 volt. And what is the charge induced on this? C is equal to Q by V, which is equal to 4 pi epsilon naught r. What is the potential? 1 volt. So, this will become 4 pi epsilon naught r into 1, 4 pi epsilon naught r. Now, this is enclosed with what is the charge induced on this one is Q, because it is connected to the potential of 1 volt. But question, what is the question here? Is asking how much is the flux coming out of the bigger sphere whose radius is capital R. What is the net electric flux? Flux coming out of any closed surface is equal to charge enclosed. So, what is the charge inside this one? It is a Q. How much is that? It is 4 pi epsilon naught into small r. So, you must be careful with the small r and capital R's. So, it is the option A is the answer. Directly it is the gate electrical question, 2 marks. Fine. So, these are the some of the sample questions. See, the main intention of this session is to show you what is the level of questions asked and what are the areas you must focus and what kind of approach you should develop in dealing with this subject for your ISRO exam. Fine. So, hope this session would have helped you, and keep preparing and make some short notes. It is a small subject, but a proportionate weightage is there in your exam. Okay. So, I will wish you very success for your exam. All the best. May God bless you all. Thank you.